Hey guys, I hope you're having a good day. Happy Tuesday. Okay, I think I figured out a way to make my tablet work. It's being a little quirky. So here we go. Our target is that we're going to be able to solve systems of linear equations by graphing at first. We're going to talk about graphing because there is a more efficient way. All right. Title this Systems of Linear Equations by Graphing, and your essential question is, what is the solution to a system of linear equations? First of all, a system of linear equations is a set of two or more equations. Remember yesterday we talked about what symbol we use when we're talking about a system, and we use this symbol. This means system. Okay, you list the two equations, one on top of the other. You put this little symbol here, and you're telling your reader, this is a system. Okay, the solution to a system of linear equations is the point of intersection. And I love how our book talks about it. It's the point of intersection, so where the two cross. Okay, let's go ahead and get started on some examples. All right. Go ahead and include these steps for your reference. Here's what I'm going to be doing each time I go through the examples. I'm going to graph them on the same coordinate plane, okay, and then I'm going to estimate the point of intersection because graphs can't always be accurate, especially if we're hand drawing them, okay. There's a more accurate way, and then we're going to take the points from step 2, the point where they cross, and plug them into the equations to check to make sure that we did this right. Okay, here we go. Our first example, our first 3 examples are going to be in y equals mx plus b, the easy way to graph. So let's talk about how to graph this easily. And I'm going to give them colors because they're on the same coordinate grid and I got to distinguish both of them. Okay, so for number 1, let's go ahead and give this one, we're going to put this one in black. So I'm going to put that right there. That's kind of a big marker. Okay, so x minus 1, negative 1. Put the intercept on. The slope is 1 over 1, so rise 1, run 1. Rise 1, run 1, rise 1, run 1. Now I'm including all of these points in here just so I can try to make my line when I sketch it accurate. You should be using a straight edge, and you guys are so good at that. Alrighty, now I'm going to go ahead and connect my dots to the best of my ability. Alright, line number 1. Okay, let's go ahead and plot line number 2. Oh, I didn't change the color. Line number 2, there we go. Okay, 3, intercept, slope, rise 1, run. Oh, fall 1, run 1. And I've already crossed my 2 points, so I found the point of intersection. I just need to finish graphing. The point of intersection should be obvious when you're graphing. It's the point at which the lines cross. And right here is the point at which these lines cross. So the number 1, the point of intersection is parentheses, 2, 1. You should be putting it as an ordered pair. It should be listed. Okay. Let's go through and check our work. If we plug this into our first equation, we should get 1, because that's y, equals 2 minus 1. So here's me checking. 1 equals 2 minus 1 is what? 2 minus 1 is 1. Good, so that did work out. Okay. And then we should be getting the same thing in for this point right here, okay? Y equals, I'm going to point number 2, equation number 2. Sorry. 1 equals negative 2 plus 3. 1 equals 1. Great, we did it right. All right, let's move on to number 4. Pause the video because I'm going to erase the board. All right, number 2. We're going to graph this. Obviously, this goes to 14 and my graph doesn't. So I'm going to change these to going by 2s. We're going to go by 2, 4, 6, 8, 10, 12. And this will be 14. So we're going by 2s. Okay. We're not going by what's listed here. All right. Intercept 14, so put a point at 14. This line's going to be in black. Okay, and then I'm going to go down 5 over 1, down 2, down 4, down 5 over 1, down 2, down 4, down 5 over 1, 2, 4, 5 over 1. Okay, hopefully I have enough of a sketch to see where they cross. All right, let's go to our next one. Our next one, we're going to put in this teal color again. All right. Intercepts at negative 10, negative 2, negative 4, negative 6, negative 8, negative 10. And we're going to rise 1, run 1. Rise 1, run 1. Oh, these are like baby steps. Rise 1, run 1. Okay, since my graph is not accurate, now we're going to estimate the point of intersection. Okay, I'm going to say this point right here is probably the closest. Okay, so I'm going to choose 4, comma, negative 2, 4, 6. Negative 6. Remember, I'm going by 2's for this problem. Okay, let's go ahead and check to see how accurate we are. Plug in negative 6 equals negative 5 times 4 plus 14. So this is our first equation. Let's plug into our second equation. Negative 6 equals 4 minus 10. Okay, I just grabbed from our equations from above. Negative 6 equals negative 20 plus 14. Does negative 6 equal negative 6? Yes. Okay. Does negative 6 equal negative 6? Yes. They're the same answer. So they are this, that is the point of intersection. We're good. All right, let's go to example number 3. Okay, example number 3, we have y equals x. So the intercept is at 0. Okay, and we're going rise 1, run 1. Here's our line. Okay. Now let's go to our second equation. Our second equation is positive 1 is the intercept, and we're going to rise 2, 1, 2, run 1. I'm not getting anywhere closer to the line. Sorry, that one's supposed to be there. So I'm going to go work backwards. Fall 2, run 1. And now my 2 lines cross. I already found the point of intercept, point of intersection, okay, and that is at negative 1, comma, negative 1. Let's check it. Does negative 1 equal negative 1 for the first equation? Yes. Does negative 1 equal 2 times negative 1 plus 1? Negative 1 equals negative 2 plus 1. Negative 2 plus 1 does negative 1 equal negative 1? Yes. Good to go. We did it right. All right. You're not always going to see equations in this y equals mx plus b form. Okay. Sometimes you'll see equations in which you're given one in y equals mx plus b, the other one not. Okay. Or you're given that both of them aren't. What do you do when you're given those situations? Convert them. Convert them to y equals mx plus b. Or graph the intercepts and estimate that way, okay? You have those tools. You have those skills. Do what you like. I would prefer to change it to y equals mx plus b because it's easier. So our first equation for example number 4 is already in y equals mx plus b. We're good to go with that one. So I'm going to graph it. Okay, negative 7. Fall 4. Ooh, I fall even more off the graph. So let's work this one backwards. Up 4, 1, 2, 3, 4, left 1. Up 4, 1, 2, 3, 4, left 1. 1, 2, 3, 4. Let me go back and check that. 1, 2, 3, 4. All right. Sketch my line together. Oh, my pen's glitching. Okay. Finish connecting those. Oop, sorry, my tablet went a little bit haywire. Great. Let's go ahead and graph the second one. I'm going to put that one in that teal color. And let's change it so it says y equals. I'm going to take away x, and now I have y equals negative x plus 2. Intercepts at 2. Go down 1 over 1, down 1 over. Getting further, so I'm going to work this one backwards. Up 1, over 1, up 1, over 1, up 1, over 1. Point of intersection right here is, so we're looking at -3, +5. Check your work. How do you check your work is the next question. We plug it back in and see that we get the same answer out. The same answer out. Let's see if we can get that same answer out. Oh, come on, pen. Five equals -4 times -3 minus 7. 5 equals +12 minus 7. 12 minus 7 is 5. 5 equals 5. That was good. Last one. Check our last equation. -3 equals, oh, not -3. -3 plus 5 equals 2. Is that statement true? Does 2 equal 2? Yes, and since we don't have them in y equals format, we're not going to get the same, okay, the same answer. Okay, but we should see that those 2 points are true for both of them, okay, and we're good to go. Alrighty, we're going to skip example on 5 and 6 for time's sake. Let's go ahead and check in on those on your own problems. Okay, here's your 3 on your own problems. Go ahead and try these. Thanks for pausing your video. Here's what you should have for your point of intersection. No, I didn't graph them. I should see the graphs in your paper. Okay, if you didn't graph them, I can't give you full credit for this assignment yet. Okay, and go ahead and answer this essential question and go take that checkpoint. I hope you guys are having a good day.